Okay, so for the first question, you should get an answer of 19.8 meters per second. So now let's go to the next one. So in the next question, they are asking you to calculate the time it takes the ball to reach the ground. The time. So in the previous question, we found that the velocity or the speed at which the ball is going to reach the ground is 19.8 meters per second. So we can write it there. And now they are asking us to find the time that the ball is going to take to reach the ground. Okay, so this is quite simple because we now do know what the initial velocity of the ball, and we also know what the final velocity of the ball is going to be when it is reaching the ground. And we still have all the information we had. And so now all that we want to know is how long is it going to take the ball to reach the ground. So we want to know the change in time from the top of the building up to the ground. Okay, during the motion of the ball. And so with all of this information that we have, we can just go to our equations of motion and see which formula would be suitable to solve the problem. And so by doing so, let me erase this. We can start by looking on the first equation here, and immediately you can see that this would be a good formula to use because we do have the final velocity of the ball, we do have the initial velocity of the ball, we also have the acceleration of the ball, and we can solve for the change in time. So this is a good formula, easy and simple, that you can use. But if you also look on the other formulas, you can actually see that you can also use this one here because we do have the change in position of the ball, which is 20 meters. We have the initial velocity, we have the acceleration, and the change in time is our unknown that we want to solve for. And likewise, we can also use this one here. Again, we do have the change in position, we do have the initial velocity and the final velocity, and we just want to solve for the change in time. So you can use any of these three equations, whichever one that you prefer in this particular question, and you should be able to find the time it takes the ball to reach the ground. And so for demonstration, I'll just use the first one because for me, I think that's quite simple and easy to solve. So I'm going to move this one upwards so that we open some room. And then so to answer our question here, again, before you even write your formula, it's very wise to choose your positive direction. And so I'll continue to stick with the downward as the positive direction. And then I write down the formula that I'm going to use, which is VF is equal to VI plus G delta T. I like writing G instead of A for the acceleration because, I mean, this is projectile motion, so we already know that is the gravitational acceleration. And then thereafter, if you want, before plugging in the numbers, you can just rearrange, your variables in the equation so that change in time is the subject of the formula. And if you do so, you will have that VF minus VI divided by G is going to give you the change in time. So that's just some algebraic manipulation. And thereafter, you can simply plug in all the numbers. So the final velocity, as we found in the previous equation, it's 19 0.8 meters per second. The initial velocity was 0, and g, which is the gravitational acceleration, is 9.8. And by doing that, you will then be able to find the change in time, which again, you can just take your calculator, plug in the numbers, and find the answer. And of course, this is time, and it will be in the units of seconds. So that's it for this question.